Let's talk about working with legacy code. Code that looks like an archaeological site without tests. The foundation was laid out by the founders. They wanted to have something ready for the market and fast. Then there was the first major customer and the stress was enormous. Nothing came out of it eventually, but the code remained. Then came Moshe, who believed in global variables, and Ricky, who wanted to develop in Python, and so on and so forth. And then our manager comes along and asks us to make a little change. 2 hours tops. We go in and carefully make the change. It almost works. Just let's amend this condition and suddenly some other thing stops working. Hey, what's going on here? Wait, can I get some help? Let's try a different way. For instance, here's a small application for inventory management. The interface is simple and inviting. I'll just type 2 here to add to the inventory. Now I'll key 0 to advance 1 day. Quality increased by 1. We want it to increase by 2. That's all. Let's look at the code. There's one big method here, not good. Methods above 10 or 15 lines of code are a recipe for disaster. It's very difficult to understand what's going on there. What should we do? Well, the first thing to do is clean our station. We don't start making changes before the area we want to change is tidy and clean. Let's take a few steps back and look at the code from above. We'll be looking for paragraphs, sections that do something concrete and extract methods or functions from them. We'll use the IDE's refactoring capability called extract method. Nice! We can see that our main method, run, is a bit shorter. We made progress. But it is still too long. Let's look for more opportunities. As long as we are using automated tools of the IDE, we are safe. The IDE keeps us from doing things that might harm the software's functionality. Shorter now, but we can do better. Always remember that the main thing we do with code is reading it. Improving code readability is an investment that returns itself very fast. And now for the last one. Okay, now it's looking much better. 6 lines. Now it's possible to see what's going on here. Looking at it now, it seems the relevant method for us is listening loop, and it's also quite long. Here there's a section that updates quality. It seems that this is the place. Let's extract it. Better. We've decomposed this to shorter methods. It'll help us and those coming here after us. The next stage is weaving a safety net. In order for us to feel free to do what's required and do it properly, we need something to safeguard us. Unit tests are the cheapest and fastest means to do this. Unit tests directly execute methods and make sure they do what they're supposed to do. We will try directly calling our method handle item. Sometimes it is not a simple thing to do. Michael Feathers wrote a whole book about it. And indeed, there's some problem here. The method does not appear in the list. This is probably as it is defined as private. We will not hesitate in making it public. You cannot play nice guy when handling legacy code. And anyway, private is there to protect us, and so do tests. The next issue we're facing is that handle item expects a list of items. This is the doing of the automated extract. As much as we respect the IDE, we are aware of its limitations, so we'll step in and help it. We will use an IDE refactoring called introduce parameter to add one item as a parameter. This refactoring tool is very effective for handling global variables, by the way. Looking up for a minute, we can see the IDE was smart enough to update the calls for the method with a new parameter. Now, let's say goodbye to the 2 other parameters for which we have no more use. Good. Back to the test. One of the reasons these tests are called characterization tests is that sometimes we don't know what is the expected result. In these cases, we will place an arbitrary value in the expected result parameter of the assert statement, run the test and set the result. Here we go, and the test will fail. We will now copy the actual result to the expected result of the assert. Run the test again, passed. Now we'll add another assert to this test, making the safety net stronger. We'll find the values in the same method, see what comes out and set it. Running, copying the actual result to the expected result, running again and pass. Another useful refactoring method is rename. We'll make use of it whenever we understand better what does a variable represent, what does a method do, or what does a class represent. One test is not enough, we'll add more. How many tests do we need? Until we feel safe enough. Usually after the first test, after the road has been cleared, it will be easy to add more tests. Here there's something odd. We expected quality to increase by 1 each day, and here it doesn't work. However, it seems that users are used to this behavior, so we'll keep it. It might be some edge case. We don't have any intention of fixing it at this point. We just want to set the current behavior of the system as it is. And so we add more tests. We'll try various cases and set the system's behavior. We'll strengthen the safety net. Every extra test increases our confidence in understanding what the software does and allows us to make changes without fear. Another tool that builds our confidence is the coverage report. We see how many lines are covered by tests. Here we can see the percent covered. This is fine. But what's more interesting is which lines are actually covered. Let's take a look at the code and see which lines are covered. According to the green mark at the side, we can see the lines that are in conditions regarding HBRE are covered. Coverage means that tests passed through the code, but this still doesn't assure coverage of all cases. It is a good indication though. Together with the functionality covered by the tests, it feels good enough for us to move forward. We're safe. We're done with weaving the safety net. We're moving to the next stage where we change the software so it is easier to change. A good method for doing this is called refactoring to patterns. Joshua Kirievsky wrote the book on that. We will change the system in small, safe steps toward desired patterns. In our case, we would like to use the inheritance pattern so we could isolate the code we need to change. The method handle item probably belongs to item. We'll move it there using the move refactoring. Here also the IDE handles all code references. We'll test after each step. We'll make use of our safety net. We are making our way carefully. In order for us to update handle item in the inheriting class, we'll make it non-static. We'll test again. Testing is addictive. Once you get the hang of it, you can't stop. The next step is building a factory method as a replacement for the constructor. Factory methods are more flexible and allow us to hide the class hierarchy from external consumers and make internal changes easier later. We would like consumers of the class to replace the use of the constructor with the factory method. We'll change the constructor's permission from public to protected and then use the compiler to find out who uses the constructor. Now we'll go one by one and make the change. Testing again. Oh no! Oh well, it's not too bad actually. We didn't write too much code since the last time the test ran, so it wouldn't be too hard to fix this. The problem is probably here. I see I misplaced quality and sell-in. Try thinking how long it would have taken us to find this had we waited with tests longer. The unit tests guard us from going too far astray. And now, passing. The fix we did here was manual and our unit tests do not cover all of it. And so this is the place to run extra tests, either manual or preferably automated. Okay, we want to move forward. Now we'll use the factory method to add a reference to the new subclass that will handle only HBRE. We will generate the new class out of the call. Working with the IDE will save time and mistakes. Testing. Now, for the time being, we will duplicate the logic that interests us into the HBRE subclass, so later we can use it. Not forgetting to test. Inside this method is the place we need to change. We'll go over the code and leave only the logic relevant to HBRE. We are now making this piece of code simpler. This piece of code that terrorized generations of developers in our organization. Look how simple it is now. Good! We've changed the system so it'll be easier to modify and we can now make the actual change. First, let's update the tests for the new behavior. There are a lot of tests here. I will start with two simple ones and change there. The tests fail as expected. And now let's change the production code and see the tests pass. Now other tests will not pass. We do remember there is some edge case here. This is the place to call the product owner if you're not sure what is the required behavior. Hey, all the tests are passing. One last thing. The unit test passed, but we have an application here that we wanted to change. So let's see. Okay, quality increases by 2. Very good. We did our task and on the way made another step toward the system that will be easier to change. First we cleaned our station, then we weaved the safety net, then we changed the system so it'll be easier to change next time, and last but not least, we made the required change. It took us a few minutes in this clip, but in reality it should take about an hour. Thanks for your attention. Happy refactoring!